The system models a 64-channel topological data packet, arranged as a 4 by 4 by 4 cubic voxel lattice, demonstrating nonlinear data wrapping, topological energy etching, quaternion core locking, real-time spectral wave analysis, and 2D canvas graphing. In the SHD-CCP Zeta Protocol, topological node etching is an automated spatial excitation process that systematically injects energy into planar slices of the cubic voxel lattice. Rather than firing at isolated nodes at random, the etcher operates as an orthogonal phase slicing engine that simulates laser-etched energy deposition across cross-sectional layers of the 64-channel data packet. The system places 6 virtual laser emitters, etchers, in orthogonal space along the main coordinate axis. Before introducing the laser etching algorithm, we must define the spatial coordinate system of the SHD-CCP data packet. The system is composed of 64 discrete computational quaternion-based nodes arranged in a 3D Cartesian grid. To center the grid around the spatial origin, an offset parameter is calculated using a spacing factor of 10. Instead of firing at random nodes, the etching engine acts as an orthogonal phase slicing simulator. 6 virtual laser emitters are positioned outside the main bounding volume along the primary coordinate axis at a distance of the scaling factor. You can visualize the 6 emitter cones, in red, pointing inward towards the origin. The etching sweep is synchronized with a global sequence cycle variable for each frame. Every cycle updates the etching step through a modulo 18 decomposition. From sequence step, 2 operational parameters are derived. The active emitter face index determines which of the 6 directional emitters fires during the current step. Then the layer depth index determines how deep from the boundary face the laser plane penetrates into the 64-bit grid. For any selected face and layer depth, exactly 16 nodes out of all 64 are needed to satisfy directional planar conditions. Let's look closely at the spatial isolation process. For any active face and depth, the engine resolves a specific target grid index. A laser beam is a focused circular profile, not a square. Therefore, the etcher executes a radial filter on the 16 planar nodes to find the core 8 nodes. The top 8 closest nodes to the centroid are selected, then the 8 furthest corner nodes fade away dynamically for each slice, leaving only the focused circular strike zone. When the laser strikes the 8 targeted nodes, they undergo instantaneous state excitation, gaining thermal energy. The TMA intercept. The central nodes form the topological memory anchor, make up the quaternion chain core. When active, these core nodes are mathematically locked. The lasers fire, but if they hit the purple central core, the thermal energy is rejected, which means it remains enforced, preserving the structural integrity of the lattice. This enforced gravity can be offloaded via torsional Markov pumps.